radioactivity, nucleus, modern physics. That is where this question belongs to. And you see, when it comes to preparation, this is a special message to the future aspirant that modern physics is one of the area which is very, very fertile, because questions from those areas are very straightforward and the probability of question occurrence is very high. So these two things combined makes modern physics a very important topic, worth investing. And here it says that there are two radioactive substances, A and B, having decay constant 5 lambda and lambda. So that's the decay constant. At t equals to 0, these samples have same number of nuclei to begin with. And we need to calculate the time taken when the ratio of number of nuclei becomes this much. Well, although the initial number of nuclei is same, since the decay constant is different, so with the passage of time, the number of nuclei of A and B would obviously be different. And if I want to calculate that ratio, say, that's going to be n naught e raised to the power minus of 5 lambda t. Downstairs would be n naught e raised to the power minus of lambda t. That's the ratio of number of nuclei. And that has to be equals to e raised to the power minus 2 as per the given one. I think it's wonderfully simpler to solve this thing, and you solve it, the value of time would be 1 by 2 lambda. So option number 1 is the correct one. Fine, with question number 10, we have completed the first 1/3 of the solution. Now we move into the second 1/3. Question number 11. Question number 11 from hydrostatics, properties of bulk matter, and more precisely, it's from the flotation. It's a very straightforward one, not much of deviation is there. A cubical block of this much side floats in water with 30% of its volume under water. Now it says what is the maximum weight that can be put on the block without fully submerging it under water. So what I can say is that initially, L cube multiplied by density of solid, that's the mass of the cube, will be equals to 0.3 L cube into density of water. That's the first part we can say, because that's a mass which is being balanced by the upthrust. Volume inside, L is the length of the cube, so 0.3 times L is the length which is inside the water. So that's a volume inside water, density of water. That's the first part. Now it says the maximum weight that can be put on the block. So let's say that additional mass is delta M. So what will I be getting from that? I'll be getting the same M plus of delta M, but this time we are at the boundary condition, so the entire cube would be just submerged for the sake of calculation, right? So what would be the volume inside? That will be L cube multiplied by density of water. So this is essentially what has been asked. And these two equations are there. You can subtract, you may make some calculation, and we need to calculate the value of delta M, the additional mass. Be careful with the unit. That's very, very important. And this time, option number 3 would be the correct option for 11th question. Fine. Now it's time we move to the next question, the 12th question. All right, the next one from ray optics, and not a regular one which you find in your practice book, a bit of variation. Though not difficult, a bit of variation, but yes, it has really added some interest level in the question. The graph shows the variation of magnification of a thin lens with respect to the image distance. And these are the parameters which are given, and basis these parameters, we need to calculate the focal length of the lens. Okay, now here what I can do is say 1 by V minus 1 by U equals to 1 by F. That's the lens formula. And what I can write is 1 minus of V by U equals to V by F. And this will give me, you see, M equals to 1 minus of V by F. Okay, so that has helped me generate an equation which relates the magnification with the image distance. Rest all is a constant. So this is y, this is x, so clearly it shows that it's a straight line. And now just comparing with the slope, you see, the slope of this graph is 1 by f. Do not care about the negative one, sign convention and all those things would certainly take care of that. So the slope is 1 by f when it comes to magnitude. And there you get 1 by f is the magnitude of the slope, and that will be equals to c by b. So clearly the focal length of the lens would be b by c. And that b by c you find in fourth option. So the correct option for this is option number 4. Fine. Now let's move to the next one.